In this video, we are going to look at another example on the material balance of iron. So let's get into this question. In this question, it said that for producing 1,000 kilograms of pig iron of composition, 95% of iron, 4% of carbon, and 1% of silicon. Iron ore containing 85% of hematite and the rest is silicate is reduced in a blast furnace using 1,000 kilograms of coke containing 90% of carbon and 10% of what? Silicate. The flask used contain 90% of calcium carbonate, 10% of magnesium carbonate. If it is desired that the slag contains 40%, which is calcium oxide plus magnesium oxide, how much flax is required for producing 1,000 kilograms of pig iron? Assume there's no lost iron present in the slag. So for this question, what you must do now is that have your table form. So your table comprises of the materials, the iron ore, the coke, and the limestone. And then we have the hematite and the various slags and the flags that you have. So in this case, when you go to iron, let's go to the iron ore. For the iron ore, it contains 85% of what? So you write 85%. And they say the rest is what? The silicate. So for the silicate, that means that if it's 85, then 100 minus 85, which will give you what? 100 minus 85, which will give you 15. So we have 15%. Then let's move on to the coke. With the coke, it contains 90% of what? Carbon. So 90% of carbon and 10% of silicate. So we have 10%. Then we'll go to the limestone. With the limestone, it contains 90% of what? Calcium carbonate. 90% calcium carbonate. And then 10% of what? Magnesium carbonate. So we have 10%. I hope you're able to understand this table. It's very nice and help you to solve your work. Now let's go to the block diagram, whereby you're going to use the block diagram to present that. So let's take note of the question. Now for the block diagram, we know that we have the ore coming in. This is the ore. We have the limestone also coming in. Let me see, the coke rather, the coke. And the last one is the limestone. And we have the flue gases. We have slag. And we have the pig iron. So therefore, we need to indicate everything that we have here. Now, from the question, they gave us that the coke is 1,000 kilograms. And the pig iron also is what? 1,000 kilograms. And let's move on to the pig iron, the composition of the pig iron. They say the pig iron contains 95% of iron, 4%. So we have pig iron, for the pig iron, have 94 iron. We have 1% of silicon, 1% of silicon, and then we have 4% of carbon. We have 4% carbon. This is 95. Try to give you 100. Now let's go to the flue gases. The flue gases, they did give us the composition of the flue gases. Flue gases was not. That's what we have now. So then we can start. For us to start this, that's the main aim is to find the how much flax is required for producing 1,000 grams of pig iron. So for that, we need to get the amount of ore. We need to calculate for the amount of ore. So calculating for the amount of ore, that's the first thing to do. So amount of ore is the basics. Whenever a question is given to you and they don't give you the amount of ore, find the amount of what? Ore. Amount of ore. So for the amount of ore, I am going to use the iron balance. So we know that there's iron in the ore. So we have the iron in the ore, and then we have iron in the pig iron. ion, pick ion. You can also use the hematite in the as the ore and ion in that, and you can use the word any of them to do that, and you get the answer. From my previous video, I've explained how to do that. So then from that, we are going to have that the percentage of ion in the ore is 9 for the pick ion is 95, but for when you look at the table, the percentage of hematite is 85. So for us to convert that into the ion, we are going to do this. We are going to get 85 over 100 times, since we have the unknown, so molar mass of unknown over molar mass of known, and molar mass of unknown is 112 and the known is 160, because we have two. When we take the hematite, right, we have two of the what ion in hematite. That's why we had 112, and the known is 60. Then times, let's use a variable which is x to represent the ore, right? And it's equal to, for the pick ion, since we are using ion, it's going to be 95 over 100, then times 1000 kilogram. And then when you find x is going to give you 1596.64 kilogram for that. That's very simple like that. So someone may also try to use the hematite balance and the person will get the same thing. So you can try that and see whether I'll get the same thing. So after finding the amount of ore, then we go on finding the slag. In this case, that the slag was like one slag was found, which was we have the silicate. The silicate is what? The slag, right? And they were saying that 40%. So that means that when you find the slag for silicate, it represents 60% of the slag, and 40% is what? Magnesium oxide plus calcium oxide from the question. So therefore, finding the slag for the silicate balance, we know that there's silicate in the ore. We have some silicates in the ore, plus we have another silicate in the coke. If we check here, there's silicate here. We have silicate in the coke, silicate in the ore. You can see that. And then we move on. And also we have silicate in the what? Pick ion as silicon. Silicate in the pick ion as silicon. Pick ion. And then we have silicate as the slag. Therefore, when you are balancing it, therefore, let's do some substitution inside. Now, for the percentages, from the table, we know that silicate in the ore was 15%. So we have 15 over 100, then times the ore that we found, that is 1596464. It's very important to find the ore. The moment you get the ore wrong, it means that all your calculations are wrong, because the amount of ore is going to help you to find ore. So be careful when finding the amount of ore. Then we have the silicate in the coke, which is 10% in the coke. So 10 over 100 times the coke is 1000. And then we have the silicate. Let's go to the pick ion. The pick ion, we have silicon. So for us to find it in the silicate, we are going to use the molar mass of unknown, which is the molar mass of unknown here. We have it to be 60, which is the silicate, and then the over molar mass of known, which is the silicon, 28, times the percentage of the known, 1 over 100, then times the pick ion mass, which is 1000, then plus silicate slag. Then when you find it correctly, you find the silicate slag, you're going to get that SiO2 slag, or correctly, you're going to get it to be 318.68 kilogram. Now, as you know this, let me explain something here. They stated in the question that 40% represent magnesium oxide plus calcium oxide. So therefore, what you found here is 60%, right? Therefore, the silicate slag represents 60% of the slag, and 40% of the slag is magnesium oxide plus calcium oxide. So now let's continue. So as far as we've gotten the 60%, let's do ratio and proportion to get the 40%, then equate to this. then we'll get to the what? The flax that we want. So let's do that. So what you're going to do now that is, if 60% is equal to 318.68 kilogram, what to be 40%? Then we create it. So that be 60 over 40 times 318.68 kilogram, which will give you 212.05 kilogram. So that is for the what? 40%, which is this. And we are finding the what? The how much flax is used, right? Since this is a flax, this is also a flax which has been converted into this, which is the magnesium carbonate has been converted into magnesium oxide, and then calcium oxide we converted calcium carbonate into what? Calcium oxide. And these are all from flaxes. So we can get how much flax was used from here. So therefore, what you do now is that we'll let Q represent the flax, how much flax was used, right? I'm making Q to represent how much flax was used. Now, what you do now is that you are going to use, you see, for the Q, which is the flax, when you find the compositions of the magnesium oxide and the calcium oxide, for you to find the slags, you need to what? Use mass of unknown over mass of unknown. So we are using calcium carbonate and magnesium carbonate in this case. So for us to do it, we know that the molar mass of let's use molar mass of magnesium carbonate is 84. Calcium carbonate is 100. We have calcium oxide is 56, and magnesium oxide is what? 40. So therefore we are going to use mass of unknown over mass of unknown. That is the molar mass of unknown over molar mass of known times the mass of known. So therefore, let's do something here. So let's take the first one. We are trying to balance all. So for us to do it, we are combining the two, and what? You equate it to the 40%, which is 212.05 kilograms. So let's do it. So first, you're going to get bracket open. We have 90%, right? 90% of calcium carbonate. So we are going to get mass of unknown, which is the calcium carbonate. So mass of unknown, which is 50 calcium oxide, over mass of known times the percentage of known, which is 0.9. Percentage of known is what? The what? Calcium carbonate. Then times the flax used. We use K, right? Then we close this bracket. Then plus, we open this bracket. We go to the magnesium carbonate. We do mass of what? Unknown, which is 40, over mass of known, which is 84. Then times the percentage of the magnesium carbonate, which is 1%, 1 over 100. Then times what? The flax used, Q, is equal to the total, which we found 40%, right? And now it is 212.05 kilogram. And when we solve this correctly, our Q becomes 384.4 kilogram. And this is the flax use, the flax. So therefore, how much flax was used? 384.4 kilogram of flax was used. Thank you very much for watching this video.